The Humble Field Programmable Gate Array, as the name suggests, is configurable logic, adaptable to most situations, and the most successful FPGA product lines stay in the market for over a decade, or even two, and they are literally everywhere. The baseline demand for FPGAs is strong and steady, however the market has diverged into two main segments. On one side, you have large, high-performance, leading-edge chips built for infrastructure, but on the other, you have small, ultra-low power chips that go into everything else. In this white paper video today, we're going to talk about one of those FPGA companies, Lattice. Lattice's portfolio backbone consists of those legacy low-end devices to the tune of 1 billion units a year. In 2019, under the guise of new CEO Jim Anderson, Lattice committed to being more agile and investing in new product lines, unlike any other player in the FPGA space. The company launched its new Nexus line, a promise to providing multi-generational updates to the low-end segment of the market. Now, in 2022, with that same agile investment strategy, Lattice is now going after the mid-range FPGA market, which has been forgotten about by everyone for many, many years. In this sponsored video, we're going to cover Lattice's strategy to double its addressable market and what this new product line, called Lattice Avant, is all about. FPGAs have literally never been this exciting.
Well, I worked in FPGA design for several decades, and I've always found FPGAs to be very exciting, but it never ceases to amaze me how the creativity of the engineering community can tackle the new challenges of the day and bring new innovations that I never thought would be possible to deliver in an FPGA. When I think about what FPGAs were when I first started in the market, they were revolutionary at the time, but in hindsight, they seemed like such simple, easy to implement devices. And when I think about, the scale of the devices that we're building, the complexity and the performance, yet maintaining power efficiency, delivering it in very small form factors, it's just, for me, it's exciting and mind-boggling at the same time. I just love FPGA technology.
So it's hard to talk about the FPGA market without mentioning the two big companies that most people here have heard about. Xilinx is the biggest and was recently acquired by AMD for $49 billion. Altera is the other one, which was acquired by Intel for $17 billion back in 2015. Both of these companies build the physically biggest and highest performance FPGAs on the market. This hardware typically does the heavy lifting in things like switches, networking, telecommunications, high-performance compute, and rely on having lots of features with lots of everything built in. These companies release a new family of high-performance parts once every 10 years or so, and since their acquisitions have been effectively ignoring the other markets. Now that they are part of larger organizations, their goal is to integrate with the other parts of the business, like x86 compute, rather than specifically focus on the FPGA solution itself. Any new products beyond the high-performance lines often end up being trickle-down designs, unoptimized for the marketplace, and not given the first-class citizen support that those customers arguably need. This leads to higher power products that are large in silicon design and footprint, perhaps with features not needed or features on board that are disabled, using a software strategy aimed more at the hundreds of performance FPGA deployments, not the single-use security solution. So with that, insert Lattice. Lattice Semiconductor has, for decades, focused on the other end of the spectrum. Their smallest FPGA, known as the ICE or IC40, is barely 1 square millimeter packaged and requires a magnifying glass to even see properly. ICE is one of Lattice's legacy family of products focused on the low end, which also includes general-purpose FPGAs, such as ECP, SERDES, and SERDES Pro, but there's also Crosslink for video connectivity and Lattice Mac FPGAs for control and security. These followed the older model of creating the product segments one by one in a linear fashion, using teams that effectively were independent internally. In 2019, that changed with a new workflow strategy. In 2019, Lattice launched its Nexus brand with a new design philosophy. They took some of those successful legacy chips and rebuilt them on a Nexus platform. This was a push to a unified FD-SOI platform in the smallest form factors, the highest reliability, and with a faster innovation cadence, which could all use a unified software stack and access specific add-ons for faster time to market. Nexus now has 5 product parts indicated by NX in a name. These are Crosslink NX for video, SERDES NX for general purpose, Mac NX for security, SERDES Pro NX for better memory, and MacX NX for a more featureful security solution. The idea is that with the Nexus strategy, new chip variants can leverage enhancements to the design flow made through previous products, and customers can get iterative updates as required. Right now, for example, Lattice's security FPGAs are found in almost every server in the market today. In 2021, the attachment rate in servers was 80%, meaning that's an average of 0.8 Lattice chips per server. In 2022, this number is expected to be 1.2 Lattice chips per server. That's a sizable increase. With this new strategy, Lattice also recently announced that gross margins company-wide were 65%, with over 1 billion units shipped annually, more than any other or all other FPGA companies combined, showcasing that even though this is the entry-level FPGA market, there is lots of volume and lots of margin. But as I stated earlier, the FPGA players in the market either focus on the low end, like Lattice, or the high end, like Altera and Xilinx. But in this video, we're going to cover the mid-range FPGA market, which has been left abandoned with no new optimized product launch in this segment for almost 10 years. Lattice is going to launch into this space with a new product line called Lattice Avant. Avant will bring with it the successful strategy of Lattice Nexus, but apply it to a new portfolio of more efficient, more secure, more capable, and more scalable family of designs targeting communications, compute, industrial, and automotive, all with the same software platform. But before we get into the technical details of Avant, it's important to understand why Lattice is branching into this more mid-range FPGA space. As covered before, the designs in this market are often cut-down versions of bigger silicon, unoptimized for their use case. Lattice's argument here is that this market is ripe for innovation, especially with its background in both volume, low power, and low footprint designs. The official numbers are that Lattice is expecting its addressable market to grow from 3 billion a year covered by Nexus to a total of 6 billion a year with Avant, doubling potential revenue and providing a strong growth vector for the company over the next 10 years.
Well, the fact that there hasn't been a new FPGA in the mid-range portion of the market in a while is all the more reason we do need to have one. Customers' needs continue to expand. They have to constantly evolve their products, add new features and capabilities, scale their performance. And quite frankly, some of the other competitors in the marketplace, they have been really focused on scaling their own technologies, which has really pulled them up into the higher end of the FPGA market. And we've gotten a lot of feedback from our customers that they're not getting the type of technology innovation that they need in their systems for mid-range FPGAs.
Forging the Avant portfolio through a similar strategy to Nexus will allow Lattice to iterate and remain agile to growing demands in this space, while their competitors are too busy focusing on the synergies of big silicon with their new owners. The Avant portfolio will be focused around 3 main sizes of FPGA. The fundamental building block of an FPGA is the logic cell, and Lattice's current largest Nexus FPGA has 100,000 logic cells. By contrast, Avant's smallest design will start at 200,000 logic cells, that's double, with a rather small 99 square millimeter package. Alongside the 200K design will be a 300K version and a 500K version. That 500K logic cell device being the lead product of the family at only 15 by 15 square millimeters. And I think the latest numbers, as I'm recording this, are actually 15 by 13 square millimeters. The Avant line will fit into the mid-range by adding traditional high-end functionality to the new low-power designs for the mid-range. This means that the family will boast a number of I/O features that the entry-level FPGA market doesn't have, but also updated versions of I/O and processing capabilities that a scaled-down big FPGAs haven't bothered to touch. The point here is balance. Avant will have a mix of non-upgradable hardened IP that's baked into the chip at low power, and balance that with the capability of the configurable logic cells to enable soft IP in the design. For example, on the hardened logic side, the family of Avant products will include parts that not only have PCIe controllers, up to PCIe 4.0, but also a multi-programmable SERDES link up to 25 gigabit per second, support any number of industry standard or custom protocols. Also included in the hardened logic is more modern memory support, including DDR5, DDR4 down to DDR2, with LPDDR4 up to 2400 megatransfers per second. Silicon is there to enable memory training without requiring additional soft logic on a 192-bit memory interface that supports ECC. Built-in security and data reliability engine supports ECC, RSA, AES-256 GCM, soft error correction, soft error detection, and anti-tamper capabilities. Users are also free to use this block as part of a custom soft IP design. One of the key areas, though, are the flexible I/O pins, and there are up to 500 of them on the biggest configuration. The configurable logic portion also has its own qualities. Avant increases the memory per logic cell compared to Nexus, offering 32 megabits at the high end. What's interesting here is that Lattice is using a 4-input lookup table, or LUT, in its compute, rather than a 6-input LUT that the bigger players use. The trade-off here is programmability and optimization. Technically, in the same area, you can do more dense compute with 6-input LUTs. However, 4-input designs, when optimized on the 16nm process node that Lattice is using here, it enables more efficient compute on workloads that only need those 4-input lookup tables. Lattice can also tweak the frequency here based on the power budget required. For example, if a customer wants a high-powered 6-input design, the 4-input LUTs can be cascaded to provide the same as a 6-input, albeit at a lower frequency. The goal here is to help with a configurable setup, including, especially for AI, one of the main targets for the Avant family. Lattice showcases this with its 1800 DSP blocks. Each one is an 18-bit multiplier, which can do either a single matrix multiplication at 18x8, or a dot quad for 9x9, or 4 8x8 matrix multipliers. This new support for an 8-bit quantized format, and in this case especially int8, it's becoming increasingly crucial for machine learning inference workloads. Avant's competitors support only FP16 in the DSP at best, or FP32 for those super old ones. By supporting int8 natively and providing library support for common machine learning frameworks, Avant ends up at 4.5 tops of int8 at half the power, or when in a more efficient lower frequency mode, only a quarter of the power of previous designs. In some of the early data from Avant, Lattice took a typical install design that a customer might use on its 500K logic cell chip. It used 350K logic cells at 300 MHz, 400 of the I/O pins, and the SERDES links at 12 gigabits per second. When comparing to Xilinx and Altera offerings, there is less leakage with Lattice's 16nm design, a better memory subsystem, and the use of LUT4. These all contribute to power savings of anywhere from a half to a quarter. This is comparing early data to silicon that has been in the market for a decade without any updates. So you might think that only half the power isn't that impressive, but Lattice is doing this in a fundamentally smaller package as well. The 15mm by 15mm of Avant is half the size in each direction compared to the AMD Xilinx or Intel Altera offering. So a deeper look into the DSP block shows that the 7200 total int8 matrix multiplier units capable of running up to 625 MHz when the workload is sufficiently pipelined. Whether using the 8x8, 9x9 or 18x18 modes, each DSP block supports an 18-bit pre-adder and a 48-bit accumulator, ensuring accuracy. DSP blocks can also be chained together for larger multiply accumulate functions of different sizes. For example, 27x18 and 36x18 require 2 DSPs, or 27x27 and 36x36 require 4. When looking at the raw throughput, along with a smaller size package and lower power, Avant will be offering anywhere from 2 to 14x the int8 performance of anything else on the market. Avant aims to be better on all fronts than anything previously available, without sacrificing any of those key metrics in which the interested customers might want. For the SERDES support, this is where we get PCIe and Ethernet, as well as video and wireless connectivity. For the members of the Avant family that support the full 25GB link, we get up to PCIe 4.0, 25GB Ethernet, and features like DisplayPort. In PCIe mode, depending on the exact Avant configuration in use, this is visible as up to 3 PCIe 4.0 X8 links. Each of those PCIe 4.0 8 links can be split into 2 quads, meaning it can either support 2 devices up to a max X4 link each, and can be derated for power to X4, X2, or X1. With 2 quads on one link, both devices will share a single reference clock, so there are some considerations here to be made. All PCIe links support forward error correction, a built-in pipe control interface, and encode-decode levels of 8 to 10, 64 to 66, 128 to 130 for the different PCIe standards. Here's another slide saying pretty much the same thing, showcasing advanced error reporting, SR-IOV for virtualization, and each X8 solution can be run as a host or a device. There's also DMA support to bypass memory caching, which comes into focus when we talk about deterministic latency. SERDES links that support deterministic latency find themselves in a wide variety of industries. For workloads that have very strict latency requirements, Avant can run in asynchronous mode for receive alignment, enabling buffer bypass, which can cause jitter with that latency. Because different FPGA use cases have different latency requirements, especially when we talk about the automotive and 5G markets, Avant was built to support these requirements out of the box. One of the demos that Lattice is showcasing at the launch of Avant is a collaboration with one of its industrial partners. It's worth noting that for a lot of markets Lattice plays in, customers don't like to reveal themselves, so bear that in mind. But for this workload, it's about camera data ingest into a system on top of additional processing. Comparing the like-for-like FPGAs from the competition, Avant was not only able to perform the transfer workload at least 60% faster, it did it in a smaller footprint, at lower power, with fewer chip-to-chip links, with added data path functionality like DMA, and it was cheaper. On the general purpose input-output of the device, the Avant 500K supports 500 pins, which Lattice partitions out into wide-range I/O at 3.3 volts and high-performance I/O at 0.9 volts. 3.3 volt support is still in wide use and isn't usually suitable for smaller process nodes, but Lattice has it working with Avant with a few key features. For example, the iCube-C support is one of the newer standards that a number of other FPGAs competing in this space do not support. So far in this video, we've stated a couple of numbers when it comes to the frequency at which the Avant silicon can work. Lack of consistency in those numbers is a good thing, as the chip supports a variety of clock and power management techniques to improve the power. So for example, DDR memory can operate at 2.5 GHz, or data can be transferred between adjacent I/O banks at 1.25 GHz. For the main bulk of the chip, the logic cells are split into regions of around 25,000 logic cells, and each region can have 16 clocks, although the full chip has 24 global clocks or 48 half-chip clocks. Power saving, as a result, is based on these global clocks and how the clock tree operates. In order to support this, there are 11 general-purpose PLLs, each with 7 programmable outputs. Now, one of the main features that FPGAs in the market aren't usually always up to date with is security. It's all very well, using the configurable logic to support the new security standards, but it helps with power and the programmability if much of it is built into the hardened IP as possible. Lattice already puts 1 billion FPGAs a year into products, and a good number of those in the automotive, telecommunications, and defense spaces are only there on the basis of being able to remain secure. With Avant, Lattice is able to take some of that process node transistor silicon budget and apply it to ensuring that the FPGA itself is secure when it is programmed, which sounds like a really basic thing that should be done, but here we are. Avant will enable bitstream security, i.e. reprogramming, with AES-256 GCM encryption, but also authentication with ECC 521 or RSA 4096 using crypto engines built into the silicon. There's also the anti-tamper functionality and a flexible monitoring report system in place.
Now, one feature that we have that I think customers know about but may not appreciate until they get deeper into their hardware design is our hardware security engine. We have on Avant a very powerful hardware security engine that has advanced cryptographic algorithms. And this hardware security engine not only protects the IP that the customer puts inside the device, it also allows for real-time encryption and decryption of data as it's streaming through the device at up to 10 gigabit per second. And the beauty of having a hardware security engine on an FPGA is that you can continually scale the capabilities of that hardware security engine. You can advance the algorithms to fend off the scaling cyber attack threats. And we know that they're just going to get bigger and more nefarious, especially in the world of post-quantum compute. And so the beauty of having hardware security on the Avant platform is not only do you get great security protection today, it's scalable well into the future.
On the topic of error detection, one aspect that Lattice is going to push with Avant is its soft error detection performance. A soft error is induced by either radiation, stochastic thermal variability, or nearby bits having a big dance about the data they are working on, and something else gets affected. Lattice's goal here is to detect quickly, correct quickly, and/or recover quickly. According to Lattice's internal metrics, not only do we go back to the size advantage, the power advantage, the performance advantage of each set advantage, but Avant will also have an error detection advantage as well. Overall, if we do a simple competition comparison, it's quite impressive. Each of these competing products offers something in the 200 to 500,000 logic cell range, but what we're really doing is comparing a new 2022-2023 product with hardware that was introduced into the market in the first half of the last decade. There are no new memory technologies in those older products, the security was modern for the time but not today, and leveraging a latest generation process node technology brings about benefits in power, performance, and features. Overall, what's not shown here is the Lattice versus Lattice differences. For example, there are a number of automotive players that use Lattice Nexus FPGAs for object tracking and self-driving footage, but one of the demands from customers using that, in particular, was the need to process more data streams at higher frame rates, but still focusing on power, integration size, and cost, as well as the software compatibility. Using an Avant FPGA, the customer is able to simply do more video frames, or faster detection and decision making at a more efficient power target with better security and a complete software compatibility with the Nexus software stack.
As we look at the market expansion capabilities for Avant, the types of customers that we're going to be servicing are the same customers that we have today, but it will allow us to be able to implement more portions of their system and other applications within their portfolio. We already have a very broad customer base. We have thousands of customers that are using our small FPGAs today, and they have the need for mid-range FPGAs as well. So this is an opportunity for us to expand our footprint in our customers, and it's across all market segments. We have customers in compute, we have customers in communications, both wired and wireless, and we have customers in automotive and industrial. And so it really is a very versatile platform and product family that's going to allow us to service applications across a very broad range. And the beauty with the Avant platform is that it's going to leverage all the software infrastructure and portfolio that we've already put in place. All of the tools that we have today, our Radiant FPGA development tools, our Lattice Propel embedded design environment, those will support the Avant products as well. And Avant will leverage that software base that already exists. So customers will be able to use the exact same tools they've been using today in Nexus when they're doing their Avant designs.
The first 3 chips that are coming out, the 200K, 300K, 500K designs, and there will be boards and reference designs available for Lattice customers. There will be updates to the Avant platform as we go forward with newer features. We expect to see details on that soon. But if you're interested in getting involved with Lattice and these new Avant FPGAs, then please reach out to your local Lattice customer representative. Or there are additional links below if you don't know who that is. We'll make sure we get you to the right person. I would like to thank Lattice for giving me the opportunity to go into detail with their new product portfolio. For a company like Lattice who sells so many FPGAs, usually in the low end, we typically don't hear much about them. But revenues are increasing, addressable market is increasing. This is an area where the FPGAs are still in high demand, even with a mild economic downturn in semis. The automotive market is still crying out for more chips, and we're seeing FPGAs being used in many more vertical segments. The point here is that the cost of doing leading edge logic is getting expensive. It is already expensive. So if you've got a low volume solution and you don't need to build a direct ASIC, or you're doing prototyping, or you want that functional updatability as the product lifecycle goes on, then you really need to be using an FPGA. We're in a situation where the two main companies that everybody's heard of is simply focusing on the high end or integration with bigger parts of the companies they're now part of. This means that this mid-market, Lattice is doing the right thing here in building up a new product portfolio range for those markets, built on longevity and things like power, performance, efficiency, size, and pretty much really importantly, that software integration. And because I've been working with certain people who currently work at Lattice for many, many years, and they invited me to the launch event, I also got a wafer to take a bite out of. I hope you all enjoyed this white paper. It wasn't meant to be a kind of more sort of generic, jokey YouTube look at a deep technology. This is really meant to be a proper, fundamental, technical deep dive into a product like this. If you like it, give it a thumbs up. Don't forget to subscribe. If not, let me know in the comments below. But thank you all for watching, and I'll see you on the next one.